Hello. Week 23 Math Blast. List three equivalent fractions for the given number. We're starting with the fraction 3/7. Well, we know we can find equivalent fractions by multiplying by a form of 1, so we don't change the value of our fraction. So we take 3/7, multiply by 2 halves, and that gives me 3 multiplied by 2 is 6/14. Now I could also multiply 3/7 by 3/3. 3 multiplied by 3 is 9/21. And I could also multiply by 3/7 by 4/4. 3 multiplied by 4 is 12/28. And so three equivalent fractions are 6/14, 9/21, and 12/28. Now these are just some of the equivalent fractions. I could have multiplied by any form of 1. And we know anytime the numerator and denominator are the same digit, that is equal to 1 whole. You give 3/8 pan of brownies to Mrs. Cable and 1/3 to Mrs. Abruba. What fraction of the pan have you given away? What fraction of the pan is left to give to Mr. Ford? So first let's draw our pan of brownies. Okay. Now first, I need to cut up the brownies so that I can give them to Mrs. Cable. So I need 1/8. Okay, so I have my 1/8, and I'm going to give 3/8 of those away. Okay. And now 1/3 to Mrs. Abruba. So I'm going to cut it into thirds this way. Okay. Now, Mrs. Abruba, 1/3 would be 1 whole row. But notice I've already given these 3 away. So I'm going to give 3 from this row. To make up for those 3 that I've already given away. And now give the rest of this row away. Okay, so because these 3 would be the 3 that are missing right here. So if you notice, this group here went to Mrs. Cable. Those brownies right there went to Mrs. Abruba. So what fraction of the pan is left to give to Mr. Ford? Well, 1, 2, 3, 4, 5, 6, 7 out of how many pieces? 1, 2, 3, 4, 5, 6, 7, 8. 3 rows of 8 is 24. So 7/24 of the pan of brownies are left to give to Mr. Ford. A WIT group measured the length of their fingernails. The measurements are listed in the table. Use the data in the table to create a line plot using 1/8 centimeters. Then answer the questions below. Okay, so I have all of this data here, and now I need to partition my line plot up into 8ths. So I'm looking here, and my smallest is 1 whole, and I see nothing larger than 2, so I'll make this 2. Okay, now chop this in half. So I know that is 1 4/8, which is also 1 1/2. And now I need to keep chopping this up here. So I'm going to go for partitioning. Cut those. So now I have 1, 2, 3, 4 pieces. 1, 2, 3, 4, 5, 6, 7, 8 pieces. So 8 equal pieces. So there's my 8ths. So this would be 1 1/8, 1 2/8, 1 3/8, 1 4/8, 1 5/8, 1 and 6/8, 1 and 7/8, and then 1 and 8/8, or 2. And now I just need to record my data on my number line. So 1 and 1/4. Well, I know 1 and 1/4 is equal to 1 and 2/8, because this would be 1/4, 2/4. Goes right there. 1 and 1/8, 1 and 7/8, 1 and 1/8, 1 and 3/8, 1 and 3/8, 1 and 1/8, 1 and 1/2, which is equal to 1 and 4/8, 1 and 3/8, 1 and 3/8, 1, and 1 and 1/2. Now notice when I made my x's, I try to make my x's consistent so that I can easily compare the groupings here. What is the most frequent fingernail length? Well, right here is the 4 x's. That's the most x's I have in any one category. So that's 1 and 3/8 centimeter. What is the shortest fingernail length? Well, furthest to the left is the shortest or smallest number. So it's 1 centimeter. Which student had the longest fingernail length? Well, furthest to the right, 1 and 7/8. So 1 and 7/8 centimeter. Draw a model to represent the given expression, then solve. 2/3 of, or multiplied by, 21. So looking at my model here, that tells me that this whole tape is equal to 21. Now I want 2/3 of that, so I'm going to partition that into thirds. Now I know I have to have the same amount in each section. Well, the number that I can count by 3 times, or 3 times what, equals 21. That would be 7. So each one of those is worth 7, or has a value of 7. Now I need 2 of those thirds. So here is 1/3, and there is another 1/3. So that's 2/3 right there. And so 7 plus 7 is 14. So 2/3 multiplied by 21 is 14. Now partitioning this, 2/3 multiplied by 4/5. So I'm going to partition this into thirds. Okay. I'm going to shade in. There's 1/3. There's 2/3. Now 4/5. There's my fifths, and now I need to do 4/5. So 1, 2. I could shade these in, but I don't need to because I'm only concerned with the overlap. 3, 4. So this represents my 2/3. This represents my 4/5. And now when I look, I have 1, 2, 3, 4, 5, 6, 7, 8 out of a total of 15 equal pieces. Complete the hierarchy. Identify each shape by circling each name that applies, then tell which is the most specific name and why. So first I need to fill in my hierarchy. Well, I know at the very top here is quadrilateral, because we're identifying quadrilaterals. So once you have a quadrilateral, I'm looking to see if it has one pair of parallel sides. That makes it a trapezoid. If you have 2 pairs of parallel sides, you're a parallelogram. If you're a parallelogram with 4 right angles, you're a rectangle. If you're a parallelogram with 4 equal or congruent sides, you're a rhombus. And if you're all of the above, so you're a parallelogram with 4 right angles and 4 equal sides, well, you're a square. Now I need to circle all of the above that fit shape 1, and then all of the above that fit shape 2. So shape 1, trapezoid. At least one set parallel, that is true. Rectangle, looking at those angles, that is true. Parallelograms, 2 pairs parallel. That is true. Quadrilateral, four-sided polygon, true. Rhombus, for congruent. Square, well, if I've circled rectangle and rhombus, I can circle square. Because a rectangle and a rhombus, if you fulfill both of those, you are a square. So the most specific name for shape 1 is square, because, and there's several different things I could put here. I'm going to put, it is a rhombus with 4 right angles. So I'm saying, well, you're a rhombus with 4 right angles, so you're a square. I could have also said it is a rectangle with 4 congruent or equal sides. That would have been acceptable also. The most specific name for shape 2, well, let's look at shape 2. Is it a parallelogram with 4 right angles? Yep. Trapezoid, at least one set of parallel. Square, it has to have those 4 right angles and 4 equal or congruent sides, so no. Rhombus, same reason it wasn't a square, didn't have those 4 congruent sides. Parallelogram, opposite sides are parallel. Quadrilateral, 4 sides. The most specific name, well, if you look over here, the name that is furthest down the hierarchy, that would be rectangle. So the most specific name for shape 2 is rectangle, because it is a parallelogram with 4 right angles. And I did some abbreviating there just so I could fit it in. Find the mystery number. So now we have our place value right here. Might be a little hard to see in your video. I'll kind of darken that. There's our decimal point. So that's all of our place values are based on their location and in relation to the decimal point. 3 in the hundredths place. So 3 places to the left. Ones, tens, hundreds. 1 in the ones place. 8 in the tenths place, that's 1 place to the right. 2 in the thousands place, 4 places to the left. 5 in the tens, 2 places to the left. 4 in the hundredths, 2 places over. 6 in the 10,000s place. And 7 in the thousandths place. So 62,351 and 847 thousandths. Standard form and unit form. So we have 95,871 and 346 thousandths, and we need to put that in unit form. Okay, so first, how many thousands do we have? Well, I can kind of underline here. So we have 95 thousandths. Now tens, 87 tens, and thousandths, 1,346 thousandths. Okay. Normally with unit form we could write it in many different ways, but we were forced in this case to use thousands, tens, and thousandths to express this number. Now I have the unit form and I need to put it in standard form. Well, I'm going to put my decimal point here. Now first, here I kind of worked from left to right, and when I have it in unit form I kind of need to work from right to left. So I have tenths. Well, tenths are right here, so I need 108 tenths. So I have 4 hundredths, 126 thousandths. So 126 thousandths I have. 4 hundredths I have. 108 tenths I have also. Thank you. That was week 23 Math Blast.